Hello, everyone. My name is João Gabriel Malaguti. I'm a master's student at Escola Nacional de Ciências Estatísticas in Brazil, and this presentation is comparison of selection methods for lattice sampling. Most sampling theory focuses on one-dimensional populations. However, there are cases in which it is important to consider two-dimensional populations and sample accordingly. These two-dimensional populations can be natural, such as areas of a field, or constructed by the researchers in combining two variables of interest, such as places of purchases and products for the estimation of price indexes, or days in maternity hospitals, such as is used in the French longitudinal survey of infancy, ELF. Lattice sampling is but one of these methods of two-dimensional sampling. What matters is it consists in selecting NR rows and NC columns, and the cross product of which forms our sample. Now, on the selection of these rows and columns, the methods are well studied, and Bellhouse has proved that the optimum plan involves systematic sampling in some manner. However, Dunn and Harrison point out that the products that systematic sampling presents when periodicities exist in the populations have not been studied for two-dimensional populations. There are also issues when estimating the standard error for the mean from these samples, because approximate equations exist for only the plans with unique selection methods. However, one could use Monte Carlo simulation to estimate these, and therefore the design effect, without need for a formal equation, placing the plans with combined selection methods, such as plans 2 and 3, which will be used in this study, on the same level as the ones with unique or pure selection methods. For this particular study, 4 combinations were analyzed: pure simple random sampling, simple random sampling for the rows, and systematic sampling for the columns, switch for rows and columns, and pure systematic sampling. 19 populations with similar means and variances but different patterns in their distribution were created, some focusing on clusters of values and others attempting to create periodicities that could feasibly exist in reality. From these, another 2 sets of populations were made, one randomizing the rows and the other its columns. These are the heat maps of the original 19 populations prior to the creation of the other 2 sets. This simulation study consisted of taking a total of 100,000 samples for each population and sampling plan and estimating the standard errors through Monte Carlo. These values were then used to calculate the composite design effects using lattice sampling with simple random sampling selection as the baseline. Plotting these results in a heat map and controlling by population, we can see that apart from populations 2 and 4, which are highly periodical, the lattice sampling with systematic sampling for both rows and columns had the lighter colors and therefore the lowest values, and therefore the highest precisions, though the sampling plans with combined selection also perform better than the baseline plan for most populations. However, this isn't the be-all end-all. Systematic sampling does still have issues with periodic populations, though more study is needed with systematic sampling alternative plans which control for the periodicity, such as Yates and corrections or Singh's modified systematic sampling. Thank you for your time.